हेलो। हाँ जी, नमस्कार, कैसे हैं आप सभी लोग? आई होप कि आप सभी बहुत अच्छे होंगे। मेरे प्यारे दोस्तों, आज की इस क्लास में हम लोग डिस्कस करने जा रहे हैं एक बहुत ही एक इम्पोर्टेंट टॉपिक हमने आज आप लोगों के लिए यहाँ पर डिसाइड किया है और आपके इस टॉपिक का नाम है रोटेशन मैट्रिक्स। एक्चुअली ये टॉपिक जो है वो आपके लिए बहुत ही ज़्यादा इम्पोर्टेंट है। इस बार भी आप लोगों से एक क्वेश्चन इस एग्ज़ाम में पूछा गया था, ठीक है ना? तो जब भी आपसे रोटेशन मैट्रिक्स का कोई भी क्वेश्चन अगर आपसे पूछा जाता है, तो आप उस क्वेश्चन को कैसे हैंडल करेंगे, ठीक है ना? तो इस कॉन्सेप्ट को आज हम इस क्लास में डिस्कस करेंगे। बहुत ही छोटा कॉन्सेप्ट है, मात्र 10 से 15 मिनट का, 20 मिनट का आपका ये जो है कॉन्सेप्ट है। इसमें हम 1-2 क्वेश्चन भी इसके करेंगे, जिससे आपको पता लगेगा कि हम किस तरह से इन क्वेश्चंस को भी हैंडल कर सकते हैं। ठीक है भाई? तो जो भी स्टूडेंट लाइव हैं, आप सभी एक बार कमेंट सेक्शन में कमेंट करके मुझे बता दो, क्या मेरी वॉइस और वीडियो आपके पास तक क्लियरली पहुँच पा रही है या नहीं? हाँ जी। तो जैसे कि मैंने आप लोगों से यहाँ पर बोला हुआ है कि हम लोग रोटेशन मैट्रिक्स की यहाँ पर बात करें, ठीक है ना भाई? तो हम लोग बात कर रहे हैं यहाँ पर रोटेशन मैट्रिक्स, रोटेशन मैट्रिक्स। तो मैं आपके लिए बिल्कुल ऐसे ही टॉपिक्स जो है वो डेली यहाँ पर लाता रहूँगा, जिससे आप एटलीस्ट एक एक कॉन्सेप्ट करके अपने आप को मजबूत कर सकते हैं, ठीक है ना? तो आज हम रोटेशन मैट्रिक्स की बात कर देखो रोटेशन मैट्रिक्स का कॉन्सेप्ट क्या है? ये जो रोटेशन मैट्रिक्स का कॉन्सेप्ट है, इससे एक क्वेश्चन आपका एसटीआर में भी पूछा गया था 4 वेक्टर में, ठीक है ना? तो हम यहाँ पर लिख सकते हैं इसके एप्लीकेशंस जो है वो कहाँ-कहाँ पर हैं। तो अगर मैं इसके एप्लीकेशंस की बात करता हूँ फिज़िक्स में, देखो एप्लीकेशंस में सबसे पहली बात तो ये है कि अपने आप में मैथमेटिकल फिज़िक्स में भी एक क्वेश्चन यहाँ से पूछा जाता है, ठीक है ना? मैथमेटिकल फिज़िक्स में भी आपका एक क्वेश्चन यहाँ से पूछा जाएगा और वो आपसे मतलब ये मैट्रिक्स से बिलॉन्ग करता है, ठीक है? एक क्वेश्चन अगर हम मैथमेटिकल फिज़िक्स से डायरेक्टली बात करें तो यहाँ पर आपका एक क्वेश्चन बनेगा। दूसरी बात ये है कि हम क्लासिकल मैकेनिक्स में जो इसका यूज़ है, क्लासिकल मैकेनिक्स में अगर हम इसके यूज़ की बात करते हैं तो वो हमारा क्या है? स्पेशल थ्योरी ऑफ रिलेटिविटी में एसटीआर में 4 वेक्टर में, ठीक है ना? 4 वेक्टर कॉन्सेप्ट से एक क्वेश्चन जो पीवाईक्यूज़ में पहले आ चुका है, प्रीवियस ईयर में भी पहले आपसे पूछा गया है, तो आप वहाँ से भी इसको देख सकते हैं। और तीसरा इसका जो एप्लीकेशन है वो हमारा क्वांटम मैकेनिक्स में भी इसका क्वेश्चन बन जाता है। क्वांटम मैकेनिक्स में भी इसका क्वेश्चन जो है वो आपका बन जाता है, ठीक है ना? तो ये जो है यहाँ पर इनका एप्लीकेशन है, जैसे इस बार जो क्वेश्चन पूछा गया, इस मैट्रिक रोटेशन से वो आपका मैथमेटिकल फिज़िक्स में डायरेक्टली क्वेश्चन इस बार ही पूछा गया है, सीएसआईआर ने इस बार ही यानी कि जून 2023 में ही आपसे क्वेश्चन यहाँ पर पूछा है, ठीक है ना? और ये पहले यहाँ पर आ चुका है। ऐसे ही आपके क्वेश्चन जो है वो क्वांटम मैकेनिक्स में भी यहाँ से बन सकता है, तो ये टॉपिक जो है वो आपके लिए बहुत ज़्यादा इम्पोर्टेंट है। देखते हैं हम किस तरीके से इस क्वेश्चन को, इस कॉन्सेप्ट को समझने की यहाँ पर कोशिश करेंगे। देखिएगा, देखो जैसे मान लीजिए कोई पार्टिकल है और वो हमारा किसी स्पेस में यहाँ पर मोशन कर रहा है, ठीक है ना? और हमने यहाँ पर इसके कोऑर्डिनेट्स देखे, सपोज़ दिस इज़ योर एक्स एंड दिस इज़ योर वाई, ठीक है ना? हमने यहाँ पर देखा कि इस पार्टिकल के जो पोजीशन कोऑर्डिनेट है, ये हमारे क्या है एक्स, वाई है, किसी भी पॉइंट पी पर और इसका जो हमारा पोजीशन वेक्टर है दैट इज़ आर, ठीक है ना? इसका जो पोजीशन है वो हमारा क्या है आर है, ठीक है ना? ओके, प्रियदर्शनी जी का मानना है कि उनको हिंदी नहीं आते, तो यहाँ पर देखो यूट्यूब की जो क्लास है इसमें हम बाइलिंगुअली यहाँ पर चीज़ों को समझने की कोशिश करेंगे। जस्ट वी विल ट्राई टू अंडरस्टैंड इन द बोथ लैंग्वेज, सो बाइलिंगुअली हम लोग यहाँ पर पढ़ेंगे। तो लिटिल बिट इंग्लिश एंड लिटिल बिट हिंदी, so we will use the both language, okay? So please try to something इंग्लिश एंड द जो हिंदी मीडियम वाले स्टूडेंट है वो इंग्लिश को समझने की कोशिश करेंगे। So just we will manage, okay? So if any particle which is doing the motion in a space and with a coordinate of x comma y, that is at point P, the coordinates are x comma y, as you know, okay? So there is a question, what is the position vector of this particle? So just we are writing the position vector. We are writing the position vector. So this position vector that is r, that is equals to xi plus yj. This is xi plus yj. Okay. Just we are talking about a two-dimensional space, or we are talking about only a plane only. So this position vector that is r equal to xi plus yj. Okay. So there is a problem if these axes are rotated. with the with an angle theta by anti-clockwise. Okay, so just we are trying to rotate this system with an angle theta. So this x is convert into x dash. So this is your theta, and this rotation is anti-clockwise, and this y is convert into y dash, and this is your also theta. So just we can say the new coordinate of this particle, this point P, that is known as your x dash comma y dash. So my question is that what is the relation between these rotation coordinate system, which is P and P dash, and we say that the what is the relation between x and x dash with the coordinates is rotating with the angle of theta with anti-clockwise system. Okay, so this angle is equal actually with x and with y. Okay, so this is our old position vector, that is r equal to xi plus yj, but we are writing that after anti-clockwise rotation after anti-clockwise rotation, the new coordinates the new coordinates are x dash and y dash. Your new coordinate is x dash and y dash. Okay, so this r dash, that is equals to what? This is your x dash I, and this is your y dash. So this is our new coordinate system, and this is our old coordinate system. But my question is that what is the relation between x and x dash? What is the relation between x and x dash? So just we are trying to convert this r and r dash into the polar coordinate system. So in the polar coordinate system, in polar coordinate system, in polar coordinate system, this x is equals to what? This is your simple, this x dash, that is equals to simple, this is your x cos theta of I cap, and this is your y sin theta of j cap. And what is your y dash? So this y dash is nothing, that is again this is minus of x, this is your sin theta of I cap, and this is your again this is your y cos theta of j cap. So this is your relation, this is your conversion of this x dash and y dash in terms of your old coordinate system. So this is your new equation, we can say this is equation number third, and this is your equation number four. But my dear friend, just we can convert, we can calculate this equation into matrix form, because we can write the every equation in terms of matrix or vice versa. Okay, so this equation, these two equation can be converted into matrix system. So in the matrix system, this x dash upon y dash, this is x dash y dash, that is equal to what? यहाँ पर आपका क्या बचेगा? What is this in this matrix system? So this x and y are the common, and here this is cos theta minus sin theta. So this is your cos theta, and this is your sin theta, and this is your minus sin theta, and this is your what? This is your cos theta here. And in this column, just we can write what is this? This is x and y. So this is the matrix relation. Just we can say we can convert the every equation into the matrix form. So this x dash y dash, that is equals to this matrix, this 2y2 matrix, and this x comma y. So this is your old coordinate system. This is nothing. This is your old coordinate system. These are the old coordinates, and this is your new coordinates. Okay, these are the new coordinates. So my question is this: what is this actually? So this is your rotation matrix. This is your rotation matrix. But my question is that this rotation matrix is along x and along y or along z. This is a very important question for us actually, because Just we are talking about at this plane. So this particle is moving along the xy plane, the direction is going the perpendicular to it. If we are doing the cross product of two vector quantities, then we get a third vector which is perpendicular to the plane of that particular plane. That particular plane. So this particle, suppose that this particle is doing the motion in xy plane, the direction of this plane is comes out the perpendicular to this, and we can say this is your z axis. The direction of this x plane is along the z axis. So just we can write this is the rotation matrix, this is our z or theta. So we can say this is your rotation matrix along z axis with angle theta. So just you can convert the every equation. As you know, in the examination you have any angle, you have the new coordinate, you have the old coordinate. Two things are given. One is old coordinate, one is angle, or we can say these two are given, or we can say these two are given. Only one things can ask in your exam. So this is a very fantastic relation. Then you can calculate the everything which is related to the rotation of matrix about your z axis. Are you happy with this or not? Please tell me about and mention in your comment section if you have any problem related to this. So my dear friend, just we can write this is the rotation matrix about the z axis. Okay, so this is the rotation matrix. This is the rotation matrix. This is the rotation matrix about the z axis. But same as just we can write the rotation matrix about x axis. Rotation matrix about x axis. Rotation matrix about x axis. So what is the rotation matrix about x axis? Because when the question is come in your examination, then one point one line is also mentioned there. This rotation matrix is about x, y or z. Okay, so this is a very important thing actually for you. So the rotation matrix about your x axis, that is nothing, that is r of x, this is theta, that is nothing. So okay, so before going to discuss the x and y matrix, just we are writing, just please wait is a very important call for to me. Hello. Okay, so this is your rotation matrix about z axis, but this is only in two-dimensional plane. If we are writing this rotation matrix of about z in space or along the x by z, so the rz in with angle of theta in x y z plane. So this is what? This is your cos theta, and this is your minus sine theta, and this is your sine theta, and this is your cos theta. Okay, and this corner have 1, this is 0, this 0, and other two terms are also 0. So this is the rotation matrix in 3D. Okay, but we can write the rotation matrix along the n dimensional plane. N dimensional plane, because the every rotation matrix is follow some rules which is following in the pure mathematics, like in vector space, in Hermitian space, in Hilbert space also. So the every rotation matrix is a Hermitian in nature. So the eigenvalues of this rotation matrix is follow the every law, every rule which is related to your quantum mechanics or quantum tools. So this is a very fantastic point for you. This question is also asked from to you in your examination, what is the nature of eigenvalues of these rotation matrix. So just we can write and mention here the eigenvalues, the eigenvalues of every, the eigenvalues of every rotation matrix, every rotation matrix are Hermitian in nature, are Hermitian in nature, are Hermitian in nature. And you know, when the everything which is related and following the Hermitian in nature, then we can say this follow the all the laws of quantum tools. जो भी हम क्वांटम मैकेनिक्स में क्वांटम टूल्स की बात कर रहे थे कि अगर कोई पार्टिकल किसी स्टेट से बिलोंग कर रहा है, यू नो, कि अगर इफ एनी पार्टिकल विच इज रिलेटेड टू दिस पर्टिकुलर स्टेट एंड व्हाट इज द प्रोबेबिलिटी टू फाइंडिंग द पार्टिकल, you know that the every state which is showing the nature of her Hilbert space. So you know this matrix is also following the law or rules of the Hilbert space. Are you agreed with this? Yes. So this is a very fantastic point. Like Gate and Just ask this type of question. This is a theoretical question actually, and this is a really very good point for you. So this is a rotation matrix in three-dimensional space about the z-axis. Just we can write also the rotation matrix along the x-axis with this particular an angle theta. So we can write here the rotation matrix. We can write the rotation matrix with the rotation matrix along x-axis with theta anti-clock rotation, anti-clockwise rotation, anti-clockwise rotation. So actually this is a very fantastic point. Okay, so what is the rx theta? So this rx theta is nothing, that is equal to what? So this is like this is 1, this is 0, 0, 0, 0, and the same point, this is cos theta, this is your sin theta, this is your minus sin theta, and this is your cos theta. So this is the rotation matrix along the x-axis with the angle theta, and we are talking about the anti-clockwise. If you are talking about clockwise, then you will be replace this theta by minus theta. Okay, my dear friend, this is a very every line, every point is really very important. We are writing this rotation matrix when theta is anti-clockwise. If you are learn it, this is not a universal law. This is only for when we are talking about the anti-clockwise. If your question in your question this is mentioned, we are rotating with the angle of theta and which is clockwise. So in the clockwise system, this theta will replace by minus of theta. So your new matrix will be generated and that matrix will showing your correct answer. Okay, are you agree with this? Okay, so my next point is this, the rotation matrix. My next point is this, the rotation matrix along the y-axis, y-axis with theta anti-clockwise, with theta anti-clockwise rotation. So this is also a really very important for you. So what will be your ry or ry with theta? You know sx, sy and sz in spin matrix in quantum mechanics. So these rules are also really very important. What is ryx? This is similarly sx, sy and sz. So this one is comes the middle part and the all the corners have the values of 0, 0 and 0, and this cos theta is comes here. So this is your cos theta, sorry, this is your 1 and this is your 0, 0, 0 and 0 part, and this is your cos theta, this is your minus sin theta, and this is your sin theta, and this is your cos theta, this is your cos theta. So really this is a very important thing for you. Okay, हाँ भाई, यहाँ तक किसी को कोई भी प्रॉब्लम है तो प्लीज बताओ। हाँ भाई, इफ यू हैव एनी प्रॉब्लम टिल हियर then you can mention in your comment section. Okay, so this is a really very important for you. Okay, we have the two note points which is related to your rotation matrix. So one note point is that the determinant of rotation matrix is always equal to 1, is always equal to 1. Okay, and the next important point is that the eigenvalues of rotation matrix, the eigenvalues of rotation matrix are e to the power iota theta and e to the power minus iota theta. You know, the product of, this is a very simple thing, the product of eigenvalues, the product of eigenvalues that is equal to determinant of matrix, that is equal to determinant of matrix. So the product is nothing, this is e to the power iota theta, e to the power minus iota theta, so that is equals to. Okay, so these 2 points we can verify by using the basic property. Okay, so this is the verification of these 2 points, the product of eigenvalues that is equal to. Okay, and my next thing is this, the sum of eigenvalues, the sum of eigenvalues of rotation matrix that is equal to the trace of the matrix, trace of the matrix. So just we can check the trace of the matrix is similar or not in the every. So this is what, this is 1 plus cos theta plus cos, this is 2 cos theta plus 1, this is again 2 cos theta plus 1, and this is again 2 cos theta plus 1. So we can say the trace of the rotation matrix in along x, along y, and along z are the same. So we can write here again. So this is 2 cos theta plus 1, that is equals to what? This is the sum of eigenvalues. So we can write here. So this is e to the power iota theta plus e to the power minus iota theta, that is equals to 2 cos theta plus 1. Okay, so this is the very important point. So by using these 2 points we can solve the every question. Just we can solve the one question which is related to this, and in the next class we will discuss a new topic. Okay, so my question is this, which is related to the rotation of matrix. So this, your question is this: consider a vector, consider a vector p that is equals to I plus 2j plus k, I plus 2j plus k in the coordinate system, in the coordinate system x y, a coordinate system I j and k, in the coordinate system I j k, the axes are rotated in, the axes are rotated in the clockwise direction, in the clockwise direction. Okay, clockwise direction about the z axis, about the z axis by an angle 45 degree, by an angle 45 degree. The vector p, the vector p in the rotated coordinate system, in the rotated coordinate system is. Okay, so what will be your right answer? Just tell me. Okay, what will be your right answer? Please tell me what will be your right answer of this question. Okay. So please try to solve this question. It's a really very important question for you. Okay. So please try to solve this question. So what is given actually? So this is your old coordinate system. This P is what? This is your I plus this is your 2J and this is your K. And this theta is nothing. This is your 45 degree. And clockwise direction and about ZX. These 2 points are really very important for you. So this is clockwise. So this is your clockwise. Theta is clockwise. And about ZX. About Z axis. So what will be your new coordinate? What would be this vector P in the rotated system? So just we can write this. This is P dash. So what will be the value of P dash? So please tell me. This is a very fantastic question and concept. Okay. So what will we use? So the basic concept is not simple. This is x y x dash. This is y dash. This is z dash. That is equal to what? This is your rz. Okay. This is z axis. So this is your cos theta. This is your sin theta. This is your 0. This is your minus sin theta. This is your cos theta. This is 0. This is 0, 0, 1. What is your x, y, and z? The coefficient of I is 1. This is 2 and this is 1. First, try to solve this matrix and this will be your answer. But this is a clockwise actually. So we can write this theta replaced by minus theta. This theta is replaced by minus of theta. So this is minus of 45 degree. So this is your x dash, this is y dash, this is your z dash. So cos minus 45, no effect. So this is 1 upon root 2. This is minus 1 upon root 2 and this is 0. And this is plus 1 upon root 2 and this is your plus 1 upon root 2. This is 0. This is 0. This is 0 and this is 1. And this is what? This is 1. This is 2 and this is your 1. Okay. So try to do the product of these two matrix. तो इसका मल्टीप्लाई आप इसमें करेंगे तो ये हमारा क्या आ जाएगा 1 अपॉन रूट 2 प्लस यानी माइनस दिस इज 2 अपॉन रूट 2 और ये हमारा कितना आ जाएगा 0. फिर आप इसका इसमें करेंगे तो ये हमारा कितना आ जाएगा दिस इज 1 अपॉन रूट 2. ठीक है ना. आप इसका इसमें करेंगे प्लस दिस इज 2 अपॉन रूट 2. ठीक है ना. फिर इसका 0 और यहाँ पर आ जाएगा हमारा 1. तो ये आपका आंसर आ जाएगा यहाँ पर. तो देखो जब आप इसको करोगे तो ये हमारा आ जाएगा रूट 2. तो ये हमारा यहाँ पर क्या आ जाएगा अगर मैं यहाँ से 1 अपॉन रूट 2 अगर मैं एलसीएम ले लूंगा तो 1 माइनस 2 यानी दिस इज माइनस के 1 अपॉन रूट 2. ठीक है ना. और यहाँ पर क्या हो जाएगा ये रूट 2 और ये भी रूट 2 है तो दिस इज 3 अपॉन रूट 2 और यहाँ पर क्या आएगा 1. तो दिस विल बी योर आंसर एंड जस्ट यू कैन राइट द वेक्टर ऑल्सो. So your p vector in the rotating frame this is p dash. So this is equals to minus 1 upon root 2 I cap plus this is 3 upon root 2 of j cap and this is your k. So just similar one question asked in your question June 2023. Okay. So this is a very fantastic concept and question. तो आप इस तरीके से चीज़ों को पढ़ सकते हो. कल की क्लास में मैं आपके लिए एक बेहतर कॉन्सेप्ट लेकर के आऊँगा. ऐसे ही हम हर क्लास में एक नया कॉन्सेप्ट पढ़ते रहेंगे. आज के लिए इतना ही. थैंक यू सो मच. टेक केयर. खुश रहें, मस्त रहें. क्लास को लाइक ज़रूर करिएगा, चैनल को सब्सक्राइब जरूर करें और जो भी टॉपिक आप पढ़ना चाहते हैं उसको आप कमेंट सेक्शन में ज़रूर भेजें. थैंक यू सो मच. टेक केयर.